Okay, welcome, welcome. We have a good group, and thanks for coming. This is actually our first regular webinar. We've already had our orientation webinar, but this is the webinar where we actually do statistics. So let me talk about the plan. So I'll say I start out with Q&A, questions and answer, but that's not completely true because we're doing Q&A and not just starting out, but throughout the whole time. If you have any questions, please ask. You can say them, or you can put in the chat box. I'll always have an eye in the chat box, do my best to read it and answer, and also have an ear in the on the speaker. And I'll be always happy to answer any questions you might have. And the content that we're going to be doing today, we're going to be looking at sampling techniques. That's actually very important and actually very difficult in the real world. It's not that necessarily that hard in our class because we just do it in theory, but to actually, get a good sample of 1,000 people, maybe of Americans or something, is very difficult in the real world. I mean, it's not going to be done in a couple hours. So just let you know, but we'll talk about the different strategies and techniques that you can use to get a representative sample of the population. Then I know this is the next one, statistics that's what this class is about, but we're going to define the word statistics. So there's a special meaning to this word, and we'll talk about it. Then we'll also look at charts. I'm sure you've seen most of them, like histograms and box plots and pie charts. We're going to look at those, and we're going to look at the, what benefits each chart gives and why you might use them. Then we're going to look at what's called the Z-score and talk about how that can be used and what it tells us. Again, right now, you probably have no clue what that means, but if you do, you know it's important, and if you don't, you'll find out. So, and then finally, we'll just look at variables. Today is kind of basic statistics and also a lot of vocabulary. So I just want to let you know about that. And I want to remind you again, if you didn't watch the orientation, you need to watch the orientation. Make sure you do the secret word quiz for that. There will be a secret word for today too, which will be different than the orientation secret word. Just let you know that. And this is the only week that has 2 webinars, because orientation is a whole different thing, where this is the statistics webinar. So let me ask you, are there any questions about anything? Any questions?
I have kind of a general question about your testing, but I don't know if I can reserve that for the end of the class or however you want.
You can ask it now. I mean, if it's not a 30-minute, conversation, we can do it now.
Okay, just real quick. I'm actually a student from a different school, and this is my first time taking a math class at your school. In your module, when you do the exam, am I going to be entering formulas within the Canvas module, or I guess how does that work? Or is it like multiple choice?
Okay, so some of it's multiple choice. So first thing, I don't know if you've looked at the homeworks yet.
Yes, I
That are
have.
due, like the chapter 1 and chapter 2 assignments.
Yes.
You'll notice that in some of those, you actually have to enter stuff in, but there's a way to do that. You click the button and you click the things. Does that make sense?
Oh, okay. Yes, yes, it does.
Yeah, and then in the questions, the last few questions are they're more written questions, typed questions, but you know what I mean? They're
Oh, okay.
open-ended questions. And on those, if you're not comfortable with figuring out how to write the formula, you can express it with meaning. So for example, and kind of what I said in the orientation is that we're going to be talking about the standard deviation, and for the population standard deviation, we use the letter sigma. That's a Greek letter, if you don't know what that is. And if you don't know how to put a Greek letter in, then you can just type SIGMA. Does that make
Okay.
sense?
Yes. Okay.
Yeah, and I won't ever take off points for that kind of typing. The only time I do want you to put in the formal equations is for the projects. Because for the
Okay.
projects, those are not like exams, they're not timed. You get as much help as you want. You're working together. I can actually work with you in office hours and show you how to put stuff in. Does that make sense?
Yes.
Yeah, so the projects are a whole different thing. But everything else, that's not putting in that's not an issue. The one thing I do suggest, and I mentioned it in the orientation also, is that if you're ever gonna, use the Canvas equation editor thing, if you're doing it for a discussion post, after you post it, make sure you look to make sure it worked, because sometimes it can actually erase your whole thing. So that's just a suggestion, because that happens once in a while. So that's one suggestion, is always look and make sure that it actually shows up. That makes sense.
Thank you.
Okay, but good question. Good question. Again, the whole point of these webinars is so that I can answer questions as they come along. Otherwise, I just say, watch the videos I've made. You know what I mean? So that's the whole point, is to be able to ask questions when you have them. Okay, so any other questions? Any other questions? Just a reminder, Thursday is the due date for your initial discussion posts that you have to do. And there's 2 discussion posts. One is just a fun one, 2 truths and 1 untruth. And the other one is from these chapters, actually. So don't forget that Thursday is the day that has to be done by. Doing it earlier is even better. But, and then Sunday is a reply to it. So I just want to remind you on that. And I will send out a message on Thursday. I always send announcements. And if you haven't already done so, either you should be checking your LTCC email every day, or you should make sure that your LTCC email is forwarded to whatever you do check, so that you can see the announcements that I set out in messages. So that is important. Make sure that you get that done. Okay, so one of the things that I love about this class is that it's used for like anything. So I can just look at the news and grab something from the news and use it for what we're doing today. And I did that. So so there's a lot of things going on in the news, but I picked one of the biggies. Most news is depressing, so sorry if this is depressing, but it usually is. And that is, there was an article, and it said that Americans are divided over US involvement in the Middle East. If you have, there was a question, how would you differentiate lowercase sigma from uppercase sigma if you have to spell it out? So you can well, if you want, you can do SIGMA with the lowercase s, and you could do SIGMA with a capital S. How's that? Sound good? Yeah. So that's one way of doing it. And there's other ways to it, but that's one way. Okay, so let me continue on. The idea is, and if you don't know about the issue in Israel right now, then your head has been in the sand for like a few months, because it's a bad one. Like all the news is usually bad. And I looked at kind of the big things, and I chose this one just because it was the first one that went up. And what the article said is 41% of the United States is doing, said that 49% say the United States doing the right amount. 39% of Americans say not enough is done. 19% say too much is done. And more Republicans than Democrats favor doing more for Israel. And a record high 47% view Netanyahu unfavorably, 33% favorably. Okay, so here's a question I have for y'all. Can we really say that 40%, 41% of all people in the United States think that the United States is doing the right amount? Yeah, how do I know that they didn't that they don't know who, the people, the Gallup is who wrote this. How do I know that they don't know? Yeah, they didn't ask you. They didn't ask me. By the way, they ask any of you? I've never had anyone say yes. I've never had anyone say yes. Yeah, they asked me. I've never had that. But one of these times, but I haven't had it yet.
but they're only talking about the people in this particular study. They're only talking about the people that were surveyed.
Well, see, that's all they have. But the way they wrote it is they just wrote Americans. They didn't say Americans that were surveyed. They said Americans are divided. Do you see? I literally copied and pasted the title of their article. So what this class is really all about is from a survey, because I'm sure you all know that they must have just done a survey, because either you do a survey or you just guess, which is even worse. But from a survey, can you say this kind of thing and get away with it? Or can you not? And it turns out there's a lot of different issues. So let me read what Gallup said about how they did the survey. So the results of the Gallup poll are based on telephone interviews conducted December 1st through 20th, 2023, which is pretty recent, with a random sample of 1,013 adults aged 18 and older living in the United States and the District of Columbia. For results based on the total sample of national adults, the margin of sampling error is plus or minus 4% at the 95% confidence level. I said that really fast because that we're not doing for a few more weeks. But I'll be really slow on it in about 3 weeks when we really get into this stuff. So, but the beginning part is what I want to look at. So I want to look at a few things. First thing, anyone guess why they asked only people 18 and older? There's actually a reason. It's a very important reason. And I'm going to bring it up for a reason about you all. Yeah, surveying minors is just almost impossible. Legally, it is really difficult. Okay, you have to go through all kinds of legal loopholes and hurdles and all kinds of stuff. So you don't survey minors unless you absolutely have to. Okay, so I want to let you know you're going to have to do a survey for your project 1. Do not survey minors. The only minors you are allowed to survey for the project, by the way, are the ones that are at our college. And that is legally their parents actually signed their rights away so that we can do it. But other than college students who happen to be under 18 that are your classmates, don't even think about surveying a minor. Got it? Okay, and I'll say this more than once. I'll say it when we talk about the project, but I want to remind you. And Gallup did the right thing too, because they're not stupid. They don't want to get sued. So that's one thing that's important. Okay. Now let's look at another thing. They said they had a random sample. Do you know what the word random means? Anyone know it? And again, I don't expect you to know what the word random is, but if you do, let me know. And if you don't, then I'll tell you. Okay, I don't see anything in the chat box about it. So let me talk about what random means. Random means that every individual, in this case 18 and older, that are in America, because we're talking about Americans, every American has an equal probability of being selected and being part of the survey. Okay, so first thing, I'm going to ask you, do you believe them? Yeah, I don't. And here's why I don't believe them. There's something called voluntary response bias. So what that means is that with a survey, and this is a telephone survey, people choose whether or not to answer the phone, for one thing. Usually if a number calls on my phone and it doesn't have their name on it, I almost never pick it up. I don't answer. Okay, I don't know about you all, but I usually don't. Okay, and then if I do and someone wants to do a survey, I usually don't have time to do it. So there's a very special kind of person that will actually answer a survey. Does that make sense? So right away, I worry about this word random. And one of the things I want you to be able to do in this class is be able to read an article's writing and see what see what you think really is true and what isn't true based on kind of understanding statistics. So here's what my guess, and I don't know for sure because I didn't talk to the people in Gallup. My guess is what they did is they randomly selected phone numbers to call. So my guess is it's not that it was a random sample, it was a random list of phone numbers that got called, and they might have called maybe 5,000 people, and maybe 1,000 of them or so, 1,013 answered the survey. Any questions on that idea? Okay, so that's one big worry that I have when I read a poll like this is that they said it's a random sample, but I know that's not possible with telephone surveys. Okay, and I want you to be able to do things like that. And I want you to understand what random means. So random means that everyone has the same probability of being selected. Okay, and that's not true because of voluntary response bias, which means you get to choose whether or not to be part of the survey. Any questions on that? Okay. And so then the big question is, and this isn't an easy one, what if you were in charge and you had a lot of, let's say, a lot of money and you had a lot of maybe personnel and time, and you wanted to do this survey? One thing is, do you think 1,000 is enough? We're not going to get deeply into this, but today. So do you know how many people there are? Maybe adults in America? I know how many people, but do you know how many people there are in America? About? It's around 340 million people. Okay, it's definitely not a couple billion. Yeah, it's not a couple million either. 340 million people, and probably 50, 60 or 70 million of those are kids. But still, we're talking about hundreds of millions of people, and they surveyed 1,013 adults. So here's a question. This is a trick question. Do you think 1,013 is enough when you have 3 million people, when you have hundreds of millions of people, if you really can do a random study? What do you think? So do you think 1,013 is enough? Okay. So again, I said it's kind of a trick question. So it turns out that if you really did a random study, then it is enough. And we're going to learn that later on in about 3 or 4 weeks. We'll realize it actually is a good sample size. But right now, you don't have the math to understand why. But you can trust me that it will be. It actually is enough if you have an unbiased survey. And again, we'll do some math and we'll see why, but not today. But I wanted to get into, a true example. Okay, they did do a minimum quota of 80% cell phone respondents and 20% landline respondents. Okay, so that actually that helps a little bit. Okay, so what they've done is they've made sure that there is no bias on what kind of phone, cell phone or landline, that the person is using. And that helps. Okay. And it turns out, and I actually went online before I started this and checked out the percentage of cell phones and landline, and it's actually not that different from 80-20. Okay. So it turns out that I think it was 27% of adults have a landline, but they also have cell phones. So that's why 80-20 makes some sense. So that actually is good. And that way they're not doing any bias based on the type of phone. They also did minimum quotas by time zone within region. Okay. And that's important because that way, at least in regions, they didn't only ask people in the East Coast or only ask people in Hawaii, which is a totally different time zone. So that's another way of reducing some bias, is they reduced it by making sure that at least by kind of regions, kind of large regions in America, they don't have bias. Okay. And they did say they use random digit methods. So that helps, but you still got that. You still have the problem with the voluntary response bias. Any questions so far? Okay, just want to let you know when you do things like, say, find out how many cell phone users and how many landline users there are, and if you find out it's an 80-20, and then you make sure that you survey 80 cell phone respondents and 80% cell phone respondents and 20% landline respondents, that's called stratified sampling, which is pretty much the most commonly used sampling there is. Stratified means that what you do is you first decide what you want to strata, make your strata. In this case, strata would be cell phone, type of phone. And then what you do is you research the percent of each type. Then you multiply that percent by your 1,000 or 1,013. And then you make sure that you establish those quotas. That's how it works. So besides cell phone and landline and time zone, what are other strata that might be used that you want to avoid bias from? What are other strata besides type of phone and time zone? Good. Yeah. So gender is definitely one. Age, race, location, political party. Okay. Now it turns out that if they're looking at just Republicans, you're not stratifying by political party, or if they're looking at just Democrats, but if you're looking at everyone, you are stratifying by it. Okay, and others might be income. That would be something you'd do stratified by. So there's lots of things you can stratify by, and it's important that you understand what it means to do stratified sampling. Any questions on that idea? All right. What else could you use besides stratified sampling? Because stratified sampling is good, but there are issues with it, and voluntary response bias is one of them. That's a biggie. And sometimes you end up just like picking the people you know, and that's not good, even though you've stratified by race. But these people that are different races, you just call them, but they're your friends, and then you got all kinds of bias. So there's other ways of doing it. So let me give you kind of the most common for college students. And that's called cluster sampling. So if you wanted to say survey, students at, say, Lake Tahoe Community College, then what you would do is you would look at the groups of students that kind of are all together. And there's kind of an obvious groups of students at a college, and those are called classes. So there's, hundreds of classes offered. And what you do is you say, well, we're going to let classes be the clusters. Then you're going to pick some of those clusters that are representative of the population. So you would probably pick some online classes. You would pick some face-to-face classes. Maybe you would make sure that you have some transfer classes like our stats class, but maybe you're going to also have some non-transfer classes like, some kind of ceramics class that is more for just community that wants to play with art. So you're going to make sure that you have a representative group of classes, and then you're going to go into each class and you're going to survey everyone in the class. And that would be cluster sampling. Any questions on that idea? Okay, so those are the two main ones, and I'll get into the others as we go, but I wanted to at least get those. If we look at this one again, a few things to look at in our survey, Gallup survey. If you look at the survey question, let's look at the answer to the survey question. So first thing, the survey question that they might have said is, do you think that the United States' involvement in the Middle East is about the right amount, not enough, or is it too much? Okay, let's see, put in the chat box what you think. See if you can answer the survey question. Okay, And by the way, this is the chat box again is not published and it's not you know, but so it's all private. You can see each other's, but no one else in the world can see it. Okay. We got some not sure, not opinion. The point of this is if you look at the possible answers that you can answer, is that you end up with words. And if your survey question has word answers, then we call it a qualitative variable that's produced by the survey question. Okay, so this is an example of a qualitative variable. A common one that we're going to be doing a lot in this class is the yes/no question. Those are words too, yes, no. And that'll be a very special case that we're going to spend a lot of time on. But I just want to kind of give you a heads up on that. That's a qualitative variable, but it's a qualitative yes/no question. Okay. On the other hand, if the answers are numbers, then it would be a quantitative survey question. So can you think of a survey question that is a quantitative survey question? There's millions of them. Can you type in the chat box a survey question that's quantitative? Good, good. How tall are you? How many hours of sleep do you get? Okay. You can go on and on and on. The good thing about quantitative survey questions is you can do math with them because you end up with numbers, and numbers are great for doing math. I think you all know that at least. Words are a little harder. The only thing you can do with words is get proportions. But with numbers, you can get lots of things. So we're going to be doing with numbers in chapter 2, which is a big part of today. Just to note, the sample size is how many people they asked. And the letter we're always going to use for sample size is lowercase n. So we're going to see that a lot, this lowercase n. So in the case for the survey that we looked at, lowercase n, or the sample size, was 1,013. Okay. If you really didn't, you just ask the people who, you can easily find, that's called convenience sampling. So that's called convenience sampling. And they mostly did convenience sampling. They did have some slight randomness and some slight, and they also had some stratification, but there was definitely a lot of convenience in it. So convenience sampling means survey whatever's easiest. Okay, and as what I mentioned, voluntary response bias is the main bias that you end up getting when you do whatever's easiest. Okay, and there's others too that you can get. So for example, I'll give you the question, the how tall are you? Let's suppose that I did convenience sampling on how tall are you, and I did it for the first class I ever taught, which was a pre-calculus class at UCLA. Okay, and this is real, okay, even though you won't believe me. It's one I could have put in the 2 truths and 1 untruth, by the way, is the average class size in my class for the first class I ever taught was 7 foot 2 inches. Okay. Now, do you think that's a good representative sample? And do you think that's like, hey, a good guess on what the average student is for their height? 7 foot 2? Okay. You might be able to guess why it was 7 foot 2. And it's not because I'm not joking, by the way, this is real. Any guess? Like the only way it could happen. You're right about the athletes. It was the basketball. I wasn't a coach of basketball. I remember I taught pre-calculus, but all of the basketball team took my class and the coach sent them to me. And everyone, I wasn't told ahead of time. They walked in, they had to duck down, and they came back up. That'd be total convenience sampling if I just picked my first class. And I'd end up with results that are like really terrible in terms of like don't represent the population at all. Does that make sense? So convenience sampling should be avoided if possible. Okay, if there's anything you want to trust, don't use convenience sampling. Okay. So here's a bunch of sampling. So random sampling we talked about. Simple random sampling is not just that everyone has the same chance, but every group has the same chance also. And just a note about random sampling, and let's see if you can do it. Pick a random number between, just off the top of your head, pick a random number between 1 and 10 and type in the chat box. Okay. So I'm looking at them. And by the way, I rarely does anyone pick 1 or 10. It turns out, do we have any psychology majors here? It turns out that, that they've actually done psychological studies, and they found out that people don't know how to, that we don't psychologically know, are able to pick random numbers, or even random people, by the way. We just can't do that in our head. So instead, what you have to do is use a computer. And that's the wonderful thing. It used to be you pick it out of a hat, but now computers are so much easier. So that to do random sampling, you do that. Stratified sampling I talked about. Okay, that's when, again, you decide in the strata, you research the percent of each type, you multiply the percent by the sample size, and you conduct the survey, ensuring the given quotas. There is cluster sampling. That's when, again, you divide the sample into clusters, like classes, for example, and then represent the population, and then sample every item in each cluster. So again, classes are common. Other thing that's common, especially in business, in like retail business. Any guess on what the typical clusters are for people that they use? You don't know, I'll tell you. Okay, time. They'll look at like all the people that went in this 10-minute interval, survey all of them, and then they'll do a different interval, but they make sure they get a 10-minute interval on the weekend, a 10-minute interval during the week, and in the evening. So they make sure they have all the different times at which people come in represented. And they survey those little times. Because cluster sampling is easier because you just quickly do it. Okay, so that's done that way. Okay, then there's a randomized control study. Okay, so let me give you, in my opinion, the most important example study, statistical study that has happened in the last 5 years. Any guess what that is? What I think it is? You may not agree. What do you think the most important statistical study has been in the last 5 years? At least what I think. And probably you'll agree too when I say it. Any thoughts? You may not know, but when I say it, it'll make some sense. Okay, at least what I think is to make sure the COVID vaccine was effective and safe. Do you agree that that's kind of important in the world? Certainly don't want to give a vaccine to, 500 million people and kill them all, or give vaccine to 500 million people and it doesn't even work. So the way they did that, okay, the fire was pretty important, but the COVID vaccine was much more important because that was worldwide. And I wasn't part of that, but I did read it. And in fact, before I got my first vaccination shot, I actually read it because I wanted to make sure. So I read what they did, and here's what they did is they got a group of volunteers and about 40,000 of them. Okay, because again, it wasn't a high percentage getting COVID, especially at the beginning. So you got to make sure you have a pretty good sample size. And then what they did is they split those into 2 groups. A group that's called the control group and a group that's called the treatment group. Okay? And the way they split them is they used a computer to randomly select people to be in the control group and randomly select other people to be in the treatment group. Does that make sense? And then what they did is everyone got a shot, but the people in the treatment group got the vaccination. The people in the control group got a shot that didn't have the vaccination. Had something that hurt their arm, so that everyone got a hurt arm, but it didn't have the vaccination. So then what they did is they waited a few months and they watched to see was there a difference in the amount of people who got COVID for the treatment group versus the control group? And more importantly, was the people who got the treatment, were they less likely to get COVID than those who got the placebo, is what you often call it when it's the control group. Okay. And again, I'm a statistician and I cared about it. So I actually read the whole research article and they did it right. And they were able to show very clearly statistically that those in the treatment group were much less likely than the control group to get COVID. And their sample size was large enough that they had very good reason to say, yeah, let's open this up to the world. Does that make sense to everyone? Okay, and maybe you're not agreeing with me, but I think that's the most important study in the last 5 years because the whole world was dealing with it. And we're still dealing with it, but now I've been vaccinated and boosted and reboosted and reboosted because I read the statistics. And if the statistics work, then I trust it. Okay, if the statistics don't work, I wouldn't have gotten the vaccination. Okay, but they did. Any questions on how that works? Okay. So a couple important words is statistic. And by the way, the opposite of statistic is parameter. So a statistic. So a statistic is a number that is calculated from the sample data. Okay. Notice it's in red. And if you're colorblind, I'm telling you it's in red, so you don't have to even see it. Any guess on why I put it in red? Maybe I'll even do more than that, but red and bold. Yeah, it's like the most important word in the entire class. And that's why this class is called statistics. So get this one down. Okay. So then we want to say, well, what kind of numbers might you calculate from the sample data? So one of them you learn in elementary school. You don't learn this word, mean. Anyone know the other word for mean that you learned in elementary school? Yeah, average. Okay. So you learn it as average, but it turns out, and this is kind of complicated, but the word average means a few different things. In elementary school, you don't even understand it, but now you do. So the mean means that you add them up and divide by the total. That's the mean. Okay, and we're going to be using the word mean for the average. So you need to use that whenever you're doing anything. Don't use that word average. Got it? When you're talking about analyzing statistics. Okay, but there's a lot of other very important statistics. I can't go over all of them because there's like 100 of them, but I can go over some of the important ones. So here's another important one, median. That one you also learn when you're young. Did anyone remember what median means? You remember? Yeah, it's a little more complicated than the value in the middle of the data set. So if it's an odd number of numbers, then you can say it's the value in the middle of the data set. If there's an even number of numbers, there's not a middle. Like there's 4 numbers, 1, 2, 3, and 4. There's not a middle number. So you take the 2 middle numbers and average those. So the median of 1, 2, 3, and 4 would be 3.5. Because, 2.5. Because 2 plus 3 over 2 would be 2.5. So that's the median. Then there's the standard deviation. Notice that's huge and in bold. So I'll say it. The standard deviation. Why did I say it so loud? Yeah, that one's really important and not everyone understands it or even knows what it means. So the standard deviation is the measure of how spread out the data is. Okay, actually say the data are. I always forget data is plural. So it's how spread out the data are. It's a measure of that. If it's very spread out, you can have a high standard deviation. Okay. If they're all kind of close to each other, you can have a very small standard deviation. Does that make sense? Okay. And by the way, the standard deviation is always a positive number. So if you ever think it's negative, you're wrong. Okay. It can be zero, actually. Standard deviation of zero means that all the values are exactly the same because that means there's zero spread. Okay. We won't do anything where that happens, but it could happen, I guess. But typically the standard deviation is going to be some number and it's going to give you a good idea, good thoughts about how spread out things are. Does that make sense? Okay, it turns out that if the standard deviation is 3. Well, let me get to this a little bit, the z-score, and I'll get to that. So another really important is what's called the first quartile. Okay, so the median is the middle, like right in the middle, right? Or the average of the two middles. So if you take the lower half over here, so we got all this data, we're going to just look at the lower half. And then take the middle of that lower half. That's the first quartile because a quarter is below that spot. Does that make sense? The third quartile is instead of the average of the middle half, any guess what it is? I mean, the average of the lower half. Any guessing what the third quartile is going to be? Instead of the lower half? Yeah, it's going to be the middle. It's going to be the middle of the higher half. And that will be the third quartile. I got some terrible news for you. This is the thing that drives me the craziest when it comes to statistics. And I love statistics, but I hate this. And that is the people in charge, the Statistical Association of America, they don't have an agreed upon formula for these. So in terms of the main thing I'm going to ask you to do is understand it in ideas. I'm never going to ask you for a formula for first quartile or third quartile. It turns out that if you use, say, an Excel spreadsheet, it'll give you a different third quartile and first quartile than if you use, say, a T84 calculator. They use a different formula. Isn't that terrible? You get someone pretty close to each other. And if it's a very big sample, there's no problems. It's almost the same. But I want to give you a heads up that if you're using one type of calculator and your friend is using a different one, you might get something a little bit different, even though you both did it right. Isn't that terrible? Sorry about that. And I wrote a letter to them, but they said that they couldn't make an agreement because they don't get along, I guess, or there was too much arguing about it. So didn't work. Okay, the interquartile range, which we often use IQR for, that's just the third quartile minus the first quartile. And what's good about that, and also sometimes you'll say it's the first quartile to the third quartile. And that's what has to do with context. So that's kind of the middle 50% is the interquartile range. Okay, so if you want to look at kind of your middle group, then that's the interquartile range. And sometimes you'll say how far apart they are from bottom to top of the middle group. That would be the IQR. Any questions on that so far? All right, and then finally, another very important one, which I'm putting in red, and maybe I'll bold that one too because it's that important, and that is the z-score. The z-score, we have a formula for, and that's x minus, and this is a Greek letter. I'll make it bigger because it might be hard to see because it's kind of small. There we go. And you know how to read this letter right here. And here's a hint. The one who's best at reading this letter is my cat. Because she says, mew, mew, mew. That's how you read it. It's mew. And it's a Greek letter. And it's the letter you use for the population mean. Okay. And then I mentioned this earlier, this letter, that is sigma. And that's the standard deviation for the population. Okay? Whereas x is a value that you want to look at. So the z is x minus mu over sigma. And I want to give you a big reminder, if you do this in a calculator, and you just type, say, 5 minus 10 over 2, if x was 5 and mu was 10 and sigma was 2, then it'll give you the wrong answer. Because of order of operations, for a calculator, you need to put parentheses, 5 minus 10 and the parentheses, and then divide by 2. So just a reminder, it's a common little math error people make, is they forget to put parentheses around the x minus mu when they do a calculation, which you have to do because that's how order of operations work when you have a big, long division sign. It means you have to do the numerator first, and then you divide. Whereas if you don't do that, if you write x minus mu over sigma, order of operations says you do the division first and then subtract. So that's just a common error, and I figured I should mention it. Okay, so the z-score gives you an idea of how far away that value is in terms of how rare it is to be that far away. It turns out if the z-score is bigger than 3 or less than -3, it's really unusual for that to happen. If it is bigger than 2 or less than -2, it's pretty unusual, like only a 5% chance typically of that happening. Whereas if it's like bigger than 1 or less than -1, it's not quite as unusual. That's about a 38% chance, or it's about a 32% chance, or about a 68% chance of being within 1. Okay. So I have a question for you. I want the first person who gives me an interesting thing, has to be a quantitative question that we can survey you all. So let's see if you can give me a question. The first person who does one that's reasonable, that's what we're going to use. Okay, so the question is, how old are you? Okay, that was the first question we got. So what I want you to do, and what we're going to do is we're going to use the calculator. This is the first time we actually had to use the calculator for something. And again, we do things in order. I did random number generator first because that's just like so quick. But the first main one is this one variable statistics calculator, and it's going to calculate all of those things. So what I have to do is I have to put the data and I have to separate it by commas. So what I want you to do is I want you to type in the chat box how old you are, or if you don't feel comfortable saying your age for some reason, then give me a number that is reasonable. Don't say you're 983 years old, okay? Don't say you're 1-year-old, because 1-year-olds can't take this class. Okay, so now what I'm going to do is I'm going to put those numbers in the chat box. I mean, in this line. So you have a 25, comma, 19, comma, 27, comma, 19, comma, 22, comma, 18, comma, 39, comma, 18, comma, 18, comma, 16, comma, 28. And then that might have been the last one. Yep, that was the last one. Any questions so far? Okay, then you have to say, do you want to consider this as a population, or do you want to consider this as a sample? And that makes a difference. If we consider it as a population, then all these numbers will not be statistics, they'll be parameters, because parameters are numbers you get from a population. If we consider this as a sample, then we're going to be looking at all the values as statistics. Does that make sense to everyone? Any questions on that? Okay, I'm going to look at this as a sample of maybe online statistics students. So I'm going to consider this to be a sample. Okay, and this has to do with just what you consider. I'm considering this to be a sample of all online statistics students at community colleges in California. Okay, we could consider this as all the people who are in our Zoom room. Okay, and all the students that are in the Zoom room, and then since you all gave me an answer, then it would be a population. Do you see? So it has to do with, do you think the population is just the people who answered, or is the population some bigger group? So I'm considering it to be a bigger group. Then I hit calculate. I try to make this really easy. All you do is you type in the numbers, separate it by commas, choose population or sample, and hit calculate, and that's it. There's nothing else you have to do. Okay. I do want to give you a little bit of a heads up. It's wouldn't for age, but let's say I asked, instead of that, I asked what your income was. And let's say someone made, $33,256. What you can't do is type in 32,256. Because you're used to doing that to separate the thousands from the hundreds. Don't do that on this calculator, because then it'll think it's one of these commas for the data separated by commas. Does that make sense? So that's one mistake that can be done with big numbers. Don't ever use commas to separate thousands and hundreds when you're typing it into the calculator. Sound good? Okay, so now we could look at all these values. Okay, now these are, because we're looking at it as a standard, the sample, these are statistics. So the mean, I'm going to round to maybe 1 decimal place. No one cares about 10 decimal places. But let's call the mean 22.6 years old. Okay, so I don't know if you're surprised about that the average student is 22.6 years old. I'm not surprised at all. Sounds about right. Any questions on interpreting the mean? Okay, the minimum. I hope I don't have to spend a lot of time explaining what the word minimum means. I'm hoping that that's a word everyone knows. That's 16. Okay, that is the youngest student. Okay, at least in the sample. You really don't want to use minimum to do any kind of guess about the population. Okay, it doesn't make any sense, actually, it turns out, because samples aren't good for that. Okay, Q1. Do you remember what Q1 stands for? It's 18, but do you remember what it meant? That was in the list of things that I had that we just talked about. Yeah, it was the first quartile. So that means that about 25% are at or below 18 years old. Okay. Oh, by the way, just a note for exams and for discussion posts, I don't take off points if you make a spelling error. So don't have to worry about it. But you should have spelling right for your projects, because that's a whole different kind of thing. Because you're working together and you can check each other's work. Okay. Okay, the median is 19. Okay, so that's kind of that halfway, right in the middle is the 19-year-old. Does that make sense to everyone? Q3, it's 27. So that means around 27% are at or below, 75% are at or below 27 years old, or about the top 25% are older than 27 years old. Any questions on that idea? The maximum is 39. So the oldest person is 39 years old. The standard deviation is about 6.8. Is that big, by the way? Okay, and that's kind of relative to what we're thinking about. I think it's pretty big. It means that most of the students are not all within a year or two of each other. Do you see that? Because the standard deviation kind of gives you an idea of how far from the mean kind of most of the students are. And if they're, about 6.7568 or about 6.8 years from the mean, that means that we have a spread. We have a common spread of around 13 years, which is a pretty big spread for age. Does that make sense to everyone? So it's really important to understand standard deviation. We'll be talking about it more too throughout the whole course. Okay, it's a big part of Project One, by the way, which I'll be talking about next week. The variance turns out to be the square of the standard deviation, and I'm not going to really get into it, but some other classes, other colleges wanted me to put it there, so I put it in there. So we're not going to use the variance. It turns out the units for the variance would be square years old, which is like ridiculously silly and unimportant. No one cares about how many square years you are. Okay, whereas the units for standard deviation would be years old. And that's what we're really looking at. IQR is 9. So again, that means the middle 50% of the sample has a distance of age of 9 years from lower to higher for that middle 50%. Any questions on that? And the sample size is 11. That means that 11 people answered the survey. By the way, what kind of sampling is this? Since we spent the first 20 minutes or so talking about sampling techniques, what kind of sampling is this? Yeah, this is definitely convenience sampling. I just asked whoever showed up to the webinar, how old are you? It's totally convenience sampling. Let's see, can you expand on IQR a little bit? Okay, so the IQR gives you the range of the middle 50%. So in this case, it's 9 years. So if we basically said everyone in the middle 50% of the age group you stay here and everyone else leaves, then there's of that group, there's a 9-year age span. Does that make sense? It's because you're cutting out the bottom quartile and you're cutting out the top quartile, and you're only looking at the middle 50%. And that's the range of that group. And it's important because often that tells you, of the middle group, are they all over the place or are they close to each other? In this case, they're pretty all over the place. 9 years is a big gap for student ages. If any guess on what would it be? Let's say I went to UCLA, where I first taught. I was a graduate student there. And we looked, and I did the same survey of, say, a face-to-face class of a stats class at UCLA. Do you think the IQR would be 9? Yeah, the IQR would probably be like 1. Because almost everyone is between 18 and 22 years old. There might be some 17-year-olds and maybe some 23-year-olds, but most everyone is like right in that, fresh out of high school age group. So the IQR there would be really smaller. Do you see how that works? So the IQR gives you a nice idea of that. Just note on just about all the calculators I've made, I have a button that says scientific calculator. If I click that, this allows you to just do a regular calculator. Okay, so I could do 8 times 9 if I wanted, and it gives you 72. It also allows roots and squares and powers and pi. And we're not going to do sine, cosine, tangent in our class. We won't do pi either. It has fractions, parentheses, decimals. So it does all the things you might be interested in. Okay, so, and this is actually Desmos that I've embedded into this. I framed in. Okay, any questions on that? Okay, so that's kind of nice to have right there in the calculator. Okay, so that's kind of the calculator. That's how you kind of use all this stuff. Let me do some more examples. Okay, so suppose that, okay, not suppose because this is actually true. My goal is to have most of the students in our class pass. Okay, I'm not some evil person that I want to fail everyone. I do not want to fail you, by the way. I really want you to pass the class. You have to do the work, and I will pass you. If you do the work and you learn the stuff, then you will pass, and that's what I really hope. Okay, and if you remember from the orientation, you have to get a 70% or higher for the course grade. That's a passing grade. Okay. If the average is 74%, am I satisfied with my goal? Did I meet my goal? If the average was 74%. And the answer is you don't know. You can't say yes. It might be that most of the students in the class got 69%, and there were a few that got 100%. The average would be 74%. Do you see how that would work? Because those 100% people would bring up the average a whole lot. The 69 is not that far from 74%. Do you see that? And we'd have a very big standard deviation. Okay, on the other hand, let's suppose I told you the standard deviation was 0.02%. Am I satisfied? Okay, and then the answer is yes, because 70% is actually, if you take that's 74% is 4% higher than 70%. And that would be 200 standard deviations above the mean. Remember, I told you 3 is really rare. 200 never happens. So if the standard deviation was 0.02%, everybody passed the class. Do you see that? If the standard deviation instead was, let's say, 20%, then there's a good chance I'm not satisfied because I may have most of the students not pass. Do you see that? So that standard deviation really helps understand what's going on. Okay, any questions so far? All right, here's what's called the empirical rule. And sometimes they'll call it the rule of thumb, but in our class we use it the empirical rule. And here's what it says. If the shape of the distribution is normal, and a normal distribution is bell-shaped. You've heard of a bell curve? So you know that it starts low, it curves up, it goes down and goes out like that. If the shape is that, and it turns out that is the most important shape in all of statistics, and we won't understand that for a few more weeks, but just trust me. So if the shape is bell curved or normal, then there is a 68% chance of being within 1 standard deviation of the mean. Okay. There's a 95% chance of being within 2 standard deviations of the mean. And there's a 99.7% chance of being within 3 standard deviations of the mean. Any questions on that idea? How do you tell if the shape of the distribution is bell-shaped, is normal? At least in our class. Any thoughts? So one thought is, can you prove it with the age example? So first thing, we don't know if the age example is normal or not. How do you tell if you have a normal shape distribution? Any thoughts? Not about the standard deviation, actually. Yeah, graphs. You make a picture. And we're going to be doing that in our class. One of the main graphs we're going to use to decide whether you have a normal distribution is a histogram. And I'm assuming, and tell me if I'm wrong, that you've all heard the word histogram before. Okay, I'm hoping that that's something that's in common language nowadays. Okay, So a histogram is one of those ways. A histogram is great to see if you have a normal distribution, or maybe it's not normal. Maybe it's skewed left, which means you got like kind of too high. I'm sorry, it's higher on the right than it is on the left. So kind of a tail on the left. Or skewed right, which is the opposite. That means it's kind of high on the left and then it tails off on the right. Okay. It could be symmetric. Histogram, normal curves are symmetric, by the way, but there's more to them than just being symmetric. So normal, it could be uniform. Uniform, do you know why we call, you've heard this, hopefully all you've heard this in the military. What does it mean? Why do we make people wear a uniform in the military? Okay, and also in some private schools, you have to wear a uniform. In Japan, not just private schools. I lived there and all, my daughter had to wear a uniform for school. So do you know why you have to wear a uniform? Not a math question, by the way. Okay, they want everyone to basically look the same. Yeah, they don't want people to stand out because of the way they dress. Okay, they want everyone to look similar. Okay, so uniform turns out that the height of the distribution, instead of starting low, going high, and going back low, that'd be normal. Uniform means you start here and you just go like that. You don't go up, you don't go down, you just always stay the same. Do you see that? And it's just a rectangle, it turns out. And that's uniform. And then there's other distributions too. Okay, histograms are really good for that. I think what I want to do now, shoot. I want to go to the spreadsheet. The spreadsheet actually does these charts. And if you remember, you can go to the spreadsheet and find it again. Add it here. All right, I find it by the way then. So the spreadsheet, if I go over here, I put in my Google Drive, which you'll want to eventually do too. And I call it Statistics by Larry Green. Okay. By the way, if you just have to log off, pretty soon we'll do a secret word, but we're not there yet. So just watch the video at the end. Okay, so here's a spreadsheet. The first thing you need to do is you need to highlight all the stuff in column A and hit the backspace. And that just basically erases them. Then what I want to do is I want to get our data back. Let's do the data we just did. So 25, 19, 27. So 25, enter, 19, enter, 27, enter. And then let's do more. 19, 22, 18. And let's do the rest of them. 39, 18, 18. And then 16, 28. Okay, so this is a spreadsheet. Notice a spreadsheet also gives you, you don't have to calculate, you just type in the numbers, it gives you everything. Okay, it gives you all the stuff we need. And by the way, the stuff later on, we're going to get these later. Okay, and just a note, so confidence level and all that, that's going to be important, and H1 and all that, but not for the project, for example. Not for chapter 1 and 2, but histogram is important. So take a look at the histogram. Is this a normally distributed distribution? Yeah, definitely not, because notice it's high on the left and it's low on the right. And that's skewed right. Yeah, so we call that skewed right, not left, by the way. So skewed right, the tail is the direction of the skew, not the high stuff. Okay, it's skewed right. The other thing to note is that we call this unimodal. Now, you've heard before the uni. Okay, you've heard of a bicycle? You've heard of a unicycle, I'm hoping. What does uni mean? Yeah, one. So unimodal means there is one mode. Mode means the highest bar. The highest, it means there is one highest value. Whereas like a bicycle, you could be bimodal. Any guess on what bimodal means? Yeah, that would mean there would be two big bars, okay? Two modes. Typical example of that would be, let's say we looked at the height of people, of adults in, I don't know, in California. Why do you think that might be bimodal? Which it is, by the way. There's a reason why it's bimodal. Yeah, men and women, right? If you're born a male, you tend to be taller. Doesn't mean you're always taller. And if you're born a female, you tend to be shorter. Okay, and that's just the way it is, called genetics or biology. And so that's one where you get a bimodal distribution. There's often, this is kind of depressing, grades, when I look at the curve for the class, tends to be bimodal. Because there's those that actually do all the work and really work hard to make it, and they're the high scorers, and then there's those that really don't put in that much effort, and they're the low scorers. There usually isn't much in the middle. Not always, but that's typical. So sometimes that's a bimodal distribution in terms of grades for the class. Score for the class, I guess, percent. Any questions on this histogram? Okay, so that's one of the charts. There's other charts too. If you go in the spreadsheet, if you go to stats, and we go to box plot, I do want to let you know that when you go to box plot the first time, it's going to give you a warning that you might get some kind of virus from this computer, the code I wrote. I promise you, I do not put viruses into my computer coding to mess with you. Okay, but it will often tell you, are you sure you want to do this? It could be, dangerous to your computer. It's not dangerous. Got it? I don't know how to stop that from being, sent to you, but it does get sent. All right, so the box plot is often called the 5-point summary chart. And here's what it is. You have 5 lines. This lower line segment, which is 16. Any guess on what that is? Yeah, that's the minimum. Okay, the youngest person was 16. How about the highest line segment here, which is 39? Any guess on what that is? I'm hoping that should be obvious. Yeah, that's the maximum. The maximum is 39. How about this middle bar in the middle of this box? Any guess what that one is? Yeah, that's not a Q1, it's a median, because the median is the middle. Then we have the box itself, which is a very important part of a box plot. The bottom of the box, any guess on what that value is? That's Q1. And the top of the box is Q3. And the interquartile range will be the distance from Q1 to Q3. So this gives you a picture of the box plot and of the 5-point summary, because it's those 5 important numbers. Is that clear to everyone? So let me give you some good things and bad things about the box plot. One of the really bad things is that non-educated people have no clue how to read this. Okay, do you agree? So if you're giving this as a presentation to the general public, this is a bad idea. So this is often used for educated people. Okay, so that's one of the big, issues with it. Okay, so another problem with it, whereas the histogram, you can see, is really good for seeing the shape of the distribution, the fact that we definitely have a unimodal. Okay, you can't tell if this is unimodal by looking at this, can you? You have no idea. Whereas with the histogram, you can definitely tell you that it's unimodal. You can definitely see that this is very skewed. Whereas the distribution is much harder to detect from a box plot. The nice thing about the box plot is it gives you that middle 50% pictorially really well, that interquartile range. Any questions on that? Okay, let me give you another really important chart. And again, I am going to stats. And before I do that, what you have to do, see this SNL left 10 caret question mark? SNL stands for stem and leaf. 10 caret is 10 to what power? And what we're going to do, we have 2-digit numbers. So the left digit is 10 to the first power digit. So I'm going to make that a 1. Then I'm going to go to stats. And I'm going to hit stem and leaf. Okay, and this is a very different chart. One that you may never have seen anything like it before. But I use it a lot, actually. So it has some advantages and disadvantages. One big disadvantage, there's a few. One of them is it's terrible for number phobe. You know what a number phobe is? You know what that is, that word, number phobe? Yeah, fear of numbers. Yeah. People look at this, and if they're a number phobe, they're like, ah! So you don't want to, if you're talking to people that are probably number phobes, you may not want to use this one. So that's a problem. Another problem with this works great for this example, okay, which it only had 11 different numbers, it turns out. And it works really well for showing those answers. If we had 100,000 numbers, this would be a disaster because good luck fitting 100,000 numbers on a page. So it doesn't work for very large sample sizes, but it works for good sample sizes that are like, a couple hundred or less. Works well for that. And here's what it does. It actually is a histogram. Okay, but it's a special kind of histogram. So this is a histogram. First thing, this is it's written vertically, and you can do horizontally or vertically, and I program this to do vertically. So here, the kind of the x-axis, that's this right here. That is 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60, 60 to 70, 70 to 80, and 80 to 90. So this 1 is the tens. So the 6 means that we had one answer that was 16. For example, this 8 means we had an answer that was 28. Do you see how to read that? Okay, so one of the great things about a stem and leaf plot is not only can you see the kind of shape of the distribution, we can still see this is skewed right. We can still see it's unimodal. But you can actually get all of the data back if you want to. On the other hand, if you looked at the histogram, we know that there were 6 people that were between 15 years old and 20 years old, but you don't know what age each of those people were. Do you see that? With the stem and leaf, you know exactly how old everyone was. Any questions on that? So stem and leaf works great, especially with 2-digit numbers. If all the answers are 1 digit, stem and leaf doesn't do anything. Do you see that? Because this separates the digits. And if there's only 1 digit, there's nothing to do. You can't do it. I do want to let you know this bottom part, you don't have to worry about it. This is, unless you have vision issues. So if you have vision issues, then you read it instead of see it. But I figured I should mention that. Same thing with the box and whiskers that had a discussion of it. Any questions on the stem and leaf diagram? Make sense? Easy enough? Okay, I want to go back now that we've kind of the main charts, and there's a lot of others. There's pie charts. I figure you've seen pie charts. You know what they look like. I don't have to do one of those, but you can do one. Okay, so if you have 3 digits, that's a good question. Then if the 3 digits where most of them, that high digit really does happen, then what you usually do is you round to 2 digits and you just stem and leaf rounded to that, to the tens. Does that make sense? And then what you do is in this 10 power, you make that 1 a 2. Do you see how that works? And that'll round it that way. That makes some sense? Yeah, so the question is, what was the box and whiskers? Was that the box plot? Yeah. If you remember that there was a top and bottom that had these like little whiskers, they call them. That's why they often call it box and whiskers, because it's there's a box in the middle, but then there's these 2 little lines on the top and bottom, and those are called the whiskers. So sometimes they'll call them box plot, some people call them box and whiskers. It means the same thing. Okay, any other questions about this before we move on? Okay. All right, so just a note, if a value is farther than 2 standard deviations away from the mean, then we call that value an outlier. You've probably all heard the word outlier before, am I right? Okay, my guess is you've all heard the word outlier. My guess is most of you didn't really know the formal mathematical definition. And there's actually 2 formal definitions, but in our class, we're going to use this one. So if it's farther than 2 standard deviations from the mean, it's called an outlier. So get that one down. Okay? So you can find out how many standard deviations from the mean it is by finding the z-score. Because the z-score is a count of how many standard deviations away from the mean it is. We saw this formula a little while ago, but I want to remind you again, it was x minus mu over sigma. And that tells you how many standard deviations away from the mean a value is. Okay. So here's an example. Okay. Let me ask you, do we have any people who are interested in healthcare? That might be your profession? Say yes or no. I usually get some. Usually that's a common thing, actually. Okay, so we have one. And okay, so I'm giving you a healthcare example. And it's very important in healthcare, these kind of questions. So suppose you are in the hospital, okay? You're taking care of an infant. Maybe you're a nurse, okay? The infant was just born. And the z-score in weight for that infant is negative 3.7. What will happen to the child? Any thoughts? This is really important in healthcare. Okay. All right. You hope they don't die. They might die. Yeah, I don't want to be depressing. But yeah, this is probably a premature baby. And that child is going to go to the ICU. Okay, it's going to be put on support. And that child is going to be cared for and kept in the hospital because negative 3.7 means more than 3 standard deviations on the low side of the average weight. That means really, really small. And when that happens, that baby's in the ICU. Okay, does that make sense? Okay, let's say another infant was born, and that infant had a z-score of 3.1. Now, what do you think the hospital can be worried about now? Yeah, so now we're on the opposite side. We have a really big baby. This is an extreme outlier. By the way, when we have over 3 or under -3, we call it an extreme outlier. Over 2 and under -2, we call it an outlier. So there's a good chance that that baby was not born naturally. Okay, and again, I don't expect you all to understand and know healthcare, but that baby would probably be delivered via C-section because we don't want the mother to get this really badly hurt. Does that make sense? And those are the kind of things that my brother has to deal with all the time. Anyone guess why? My personal brother. I only have one brother, by the way. My brother he's not midwife, actually. He's an OBGYN, but he specializes in delivering babies. That's actually what he does for a living. Yeah. So the good news is most of his patients are happy, which is always a good thing. Whereas if you're a doctor, most of your patients usually aren't so happy because they're not happy to just have a baby. Okay, let's suppose a third infant was born, and the z-score of the third infant was -0.19. Now, what do you think happened? Or what can you say? Okay, so now -1.9 is really close to 0. 0.19 is really close to 0, which means that this baby was almost perfectly an average baby in weight. Do you see that? So in terms of weight, yeah, there's no concern at all for this baby. This is your very typical baby. Does that make sense? Because -1.9 isn't even close to -2. It's very close to 0. Do you see how that works? So that means this baby is very normal, very average. Okay? A z-score of exactly 0 almost never happens, but very close to 0 happens. Do you see how that works? Because to be exactly something on is like really, it just is very rare. Any questions at all on this idea of the z-score, which puts together the mean and the standard deviation together? Make sense? All right, we have a secret word. And the secret word is random. And if you remember, that was one of the first words we talked about statistically, is that you hope, if you can, get a random sample. It's usually impossible, but you want to get as close as you can to random. Okay, as Gallup used random digit number dialing. So at least they randomly called people. They didn't necessarily get random people answering, but they randomly called people, which is good. So random is the secret word for the week 1 webinar. Okay, make sure you write that down so you don't forget it, and you can put in the secret word quiz. And just a note, next week's webinar will be Tuesday at 1. Why is it not Monday night? There's a reason. Why is it not Monday evening? Yeah, holiday. I'm not allowed to do that. I'm not allowed to have a webinar on Martin Luther King's birthday. So I'd be breaking law, and I don't like to break laws. So Tuesday at 1 o'clock, I'm very allowed to do that. So I'm having a webinar on a week from today. I try to do back and forth Monday, Tuesday. But of course, next week there's no choice. There's another one of those where there's no choice, and that's President's Weekend is a holiday. But next Monday is a holiday. It doesn't mean that I'm not allowed to answer your emails or answer your Q&A that you post if you post something on the holiday. There's a good chance I'll be there, and checking it. But just remind you, there is a holiday. And also because it's a holiday, the tutoring center's closed. So don't expect to get tutoring help on Monday because, again, we do what we're supposed to do for Martin Luther King's birthday is we don't make people work. So I don't have the webinar, there's no tutors to, where they make them work, etc. Okay. So the webinars will normally be back and forth between Mondays and Tuesdays. but not always because of this holiday thing. That makes sense? Okay, I want to give you a note on some symbols that are really important, and then we'll call it a day. So this X, you see this X and you see this bar on top of the X? We read that X bar actually. So if you want to, it's very hard actually, unless you're really good with this kind of stuff, to type this into a computer. So typically it's fine if you write X bar like that. And that is a symbol we use for the sample mean. Got it? Sample mean is very important in this class. Okay. Then this guy we talked about is mu, like my cat would say. Meow, meow. And that's the population mean. Okay. So remember, X bar would be a statistic, mu would be a parameter. Okay. Then S is the sample standard deviation. S for standard deviation. Makes sense, right? And then sigma is the population standard deviation, because the Greek letter for S is sigma. The Greek letter for mean is mu. I do want to give you a little heads up. The other thing that we're going to be doing is proportions. And what's the problem with using the Greek letter when we're talking about population proportions? Anyone know? Here's the hint. You all know the Greek letter for P. And then you'll know why it's a problem. Anyone know? Now, the Greek letter for P is pi. I hope you all know pi, right? And if I write down the letter pi, you'll all think it means 3.14, etc. So when I first taught, actually, that's what they used. And then fortunately, about 25 years ago, they actually got rid of that. And now we don't use that anymore. We use a P for the population proportion and a P with a little hat on top. We call that P hat for the sample proportion. So those are some others that you'll see sometimes. But I want to let you know we don't use the Greek letter for P because that's pi and that's confusing as hell. Okay, and not just something I don't do, but the whole country stopped using it, which is a good thing. So that's pretty much it. That's all I have to talk about. It doesn't mean there's, more stuff. If you read the book, you'll see more. I can only do so much in the hour and a half or so that we have. But I do want to let you know, I want to remind you that Thursday, you have to have your discussion posts due. Probably by tomorrow, I recommend having partners decided on. And if you post someone to someone else's post saying, can I be your partner? And they say, I've already found two and there's 3 of us already. Don't give up. That means you should repost your own and say, hey, I'm looking for a partner. Or post someone else and say, can I be your partner? Do you see that? But don't just give up because someone said no. Okay, it usually just means they have 3 people. Okay, so that's important in terms of the project. And the other thing is, if you happen to have a learning disability, please soon contact the Student Accessibility Services, which I showed you in the webinar yesterday, in the orientation webinar. Because if you happen to need extra time, I can only give it to you if they tell me that you require it. Otherwise, I'm not allowed to. There was a question about, is there extra credit for this class? And the answer is there is no extra credit for this class, because the idea is if you want to, get more points, then do more work and you'll do better. Learn more, get work, talk to a tutor and have them help you on things that you might be a little confused in. Practice more problems. And no, you don't get more points, but you get more learning, and then you'll do better on the tests. So that's more important, is to understand it and learn it. Does that make sense? Okay, so there isn't any extra credit. Okay, so sorry about that if you wanted extra credit. So what I'm going to do, I'm going to stop the recording.